In this short animation video, you shall understand how blockchain works. How transaction messages were collected on a block and then hashed. How blocks were mined and chained with each other. And how a chain breaks if someone tries to change the block messages. You shall also understand the importance of nonce and solving hashing puzzle on blockchain network. Just watch this video to the end in order to understand how blockchain works. A blockchain is a software. It's as simple as that. We will come to blockchain concept later. For now, let's focus on Bitcoin wallet. In order to understand how these cryptocurrencies works, you need to create your wallet first. When you open your cryptocurrency wallet for the first time, it gives you a unique secret key. With those secret key, a public key is generated. This public key is generated using complex math function, which requires private key as input. Public key is used to receive funds, so your Bitcoin address is your public key, and it can be shared with anyone. The secret key must be kept secret. If someone gets your secret key, they can easily transfer all the funds to their wallets. So, creating a Bitcoin address requires nothing more than picking a random valid private key and computing the corresponding Bitcoin address. This computation can be done in a split second by your mobile or computer. But the reverse, computing the private key of a given Bitcoin address, is practically impossible. Okay. You got your Bitcoin address. Let's add some Bitcoin on it. Let's ask our friend Satoshi to send some Bitcoin. Satoshi has his own unique private and public key. There is also record on publicly available blockchain ledger that his public key has an available balance of 200 Bitcoin. This will be updated on his wallet. Okay. Satoshi is now ready to send Vitalik some Bitcoin. For that, he creates a transaction notes. He also signed his digital signature. So far, Vitalik create his unique public key using his secret key. Gave his public key to Satoshi in order to receive some Bitcoin. Satoshi prepare his transaction note for Vitalik and add his signature in it. Now we need someone to verify Satoshi notes and signature. And also update the blockchain ledger, which updates both Vitalik and Satoshi wallet. What will happen if we give this verification power to PayPal? If PayPal has the sole power to update blockchain ledger, then Bitcoin is no longer decentralized. Because PayPal got the authority to cancel transaction, temper Satoshi data, and so on. Instead, this verification power is given to the online community. It's the job of Bitcoin miners to verify Satoshi's signature and update the public ledger. The real signature doesn't look fancy like this. Real signature that Bitcoin uses is generated by using complex math function, and they appears in the form of random binary numbers. I am using fancy signature here, just for understanding purpose. Okay. I have talked about signing signature and then verifying it. But how is this done? There is no bank or authorized person to verify it. Bitcoin is decentralized. Well, signing and verifying a messages is done by using cryptic math algorithm. We can understand basic level of this algorithm by using a simple mathematical formula for creating private and public key. You can skip this part if you're not interested. Everyone picks a number S for their secret key, which they don't reveal, but they share 5 times S as their public key. Let's say Satoshi picks a secret key 10, then his computer wallet calculate his public key 5 times 10, which equals 50. Each message is converted into a number M. In this case, Satoshi message is converted to, let's say, 101. The person sending the message produces a signature to prove they're the one who sent it by calculating M times S. So the signature in Satoshi case would be 1010. The last piece of the system is that we need to be able to verify that Satoshi is the one to produce his signature. In this proposed system, we can verify a signature by checking that the following equation is true. This equation is used by miners. If left-hand side is equal to right-hand side, then Satoshi's signature is verified. So, the signature function requires message and secret key, 2 inputs. This function is used by Satoshi, whereas the verify function requires 3 inputs: signature, public key, and message. And this function is used by miners. But this system is not secured. The public key is calculated from 5 times S, so to recover the secret key we can just divide the public key by 5. Secret key can be cracked easily. Your signature needs to be something that only you can produce. This simple multiplication scheme doesn't work because anyone who understands the rules of the system can steal your secret key just by dividing. We need to be able to verify a signature without compromising the security of the secret key associated with it. Now consider public key calculated using this equation. Giving the remainder after dividing by 17 hides the secret key, since we don't know how many times 17 goes into the secret key. For example, a public key of 3 could correspond to a secret key of 3 or 20 or 37, etc. So, cracking secret key would be difficult. Most ordinary functions doesn't hide their inputs very well. You can reverse addition with subtraction, division with multiplication. Okay, that's some basic level idea on understanding cryptographic signatures. Let's not spend too much time in it. As you have seen, it requires a wallet to store, send, and receive Bitcoin. But to mine Bitcoin, we need another program. This program fully validates transactions and blocks. When you set up this program in computer, let's say Bitcoin Core, this software downloads all the blockchain database communicating with other miners. When this process is complete, you will become a node responsible for validating transactions. In other words, you are a miner now. Now, Satoshi's wallet will broadcast his digitally signed messages to the network. These pending signed message would travel and reach the mempool of miners. Just think mempool as transaction files that got deleted when fully verified. But not only Satoshi, there would be many digitally signed transaction notes that needs to be verified. They all are stored on mempool. The miners picks the transaction messages randomly. They try to sort and pick the notes that has the highest fee. Now all these miners were in competition to verify signature, and once verified they store them in a block. A block can store many transactions. When a block is full, then the miners need to find the nonce value that match the hashing puzzle. Okay. Nonce and hashing puzzle, 2 interesting keywords got introduced here. Let's understand what they are. So a transaction is verified, stacked, and then stored in a block. Not only message, a complete verified block needs nonce and a hashing string. A nonce is just a random digit, and hashing is like a fingerprint. When you hash a block only, it creates one unique random hashing string. This hashing string is a random one and unique. So with one input a block, we create a hashing string. This is a unique fingerprint. If you change any of the block message, the hash changes. But what if you want a hashing string that starts with 5 leading zeros? Of course, you are not allowed to modify the block. To generate those hash, you need another input called nonce. A nonce is a random digit. By trying to change the nonce value, you can look for 5 leading zeros. When you successfully generate the leading zeros, then you solve the hashing puzzle. So hashing puzzle was finding the 5 leading zeros on our fingerprint. When a miner successfully solve a hashing puzzle, other miners trying to solve the same hashing puzzle would get notified. They verify those blocks. Once verified, it is added on a public blockchain. Now let's understand how this block can be chained with its preceding blocks. Right now this single block is verified, hashing puzzle were solved. I mean nonce value were mined. Now in order to create chain of blocks, this block needs one additional parameter. It requires the hash of previous block. Technically, our current block stores transaction messages, hash of previous block and a nonce value. With these 3 inputs, our block is hashed. Last time, for better understanding, I didn't include previous block hash as input parameter. Let's rearrange these hash tag like this. So, these nonce, transaction messages and previous hash were hashed. They were chained to their respective hashes. And again this hash is used in another block to create new hash. Later this hash will be shared by another block. This process continues and creates blockchain. If you try to change any intermediate block, then it affects the whole block that comes after it. And these hashes again do not starts with 5 leading zeros. So the whole chain breaks. Now to chain these blocks, you again need to remine every nonce value. This is one of the simplest blockchain arrangement. And luckily Bitcoin uses this simple arrangement. But these blocks can be hashed and arranged in many ways. Here is one of the example. Let's take a look and understand how the block were chained with each other. Both of these 2 blocks were chained with this block. Again this same block hash is stored by this block. It also stores other block hashes. And finally this block hash is stored by this last block. Please research on Merkle trees to understand more deeply about block arrangement. Let's not dig deeper in it. Now let's see what will happen if someone tries to fool the system with fraudulent block. Miners, wallet owners, everybody owns the copy of blockchain. When a block is created, it just gets updated everywhere. Let's say PayPal is trying to fool Mr. Vitalik by sending a fraudulent block. For that purpose, he created a fake transaction message, put it on a block, and mined it. Now he sent the fake block to Mr. Vitalik. Okay, Mr. Vitalik received the fraudulent block. But he also still receives the block mined by good miners. This creates a block conflict. Since the block given by PayPal is distinct from the block shared by the community, there would be a fork on Vitalik blockchain. Now Vitalik requires more block for confirmations to distinguish valid and invalid block. Here Vitalik has to trust whichever ledger has the most computational work put into it. To gain Vitalik trust, PayPal has to mine all the future blocks within every 10 minutes and makes his fork longer. This is only possible if it can control over 50% of a network's mining hash rate. He needs to own the most powerful, super quantum computer. In the end Vitalik has to ignore shortest chain and has to follow the longest chain. Longest chain not only serves as proof of the sequence of events witnessed, but proof that it came from the largest pool of CPU power. You can navigate through each block by visiting the following URL: blockchain.com/btc/block/0. In order to travel through each block, just change this numeric value. Right now we are on block 0. This block were first mined by Satoshi Nakamoto in 2009 AD. This block was given a special name called Genesis block. At that time, block reward was 50 Bitcoin. Block reward refers to the Bitcoin rewarded to a miner when they successfully validate a new block. You can also call it Coinbase reward. This reward is stored in the same block as transaction messages. Every block is divided into two parts: block information and block transactions, or transaction messages. Let's extract more information of this Genesis block. Look. This block has more than 740,000 block confirmations. It means that there have been more than 740,000 blocks mined till now. The latest block is this number, -1. See right now, latest block has only 1 confirmations. This confirmations is important because the more blocks that are mined after a transaction is committed to a block, the greater the chance transaction is done and irreversible. Generally, a transaction is considered a success or completed after 6 block confirmations. Let's again go back to block 0. You can also see the nonce value that solved this leading zeros hashing puzzle. Look. At that time, the hashing puzzle has 10 leading zeros. Solving these puzzle has difficulty value of just 1. As of today, the difficulty value of mining a block has increased to about 30 trillion. It means that a miner needs to solve the hashing puzzle that starts with 20 leading zeros. It takes much computational power. Bitcoin is programmed in such a way that it takes on average 10 minutes to generate a new block. So, on average of every 10 minutes, one of a lucky miner from the community is expected to create a new block. This block creation is managed by periodically changing the difficulty value. When more and more miners were added to network, the challenges gets harder and harder. Difficulty increases. Also, the mining reward decreases with time. At the beginning, reward was 50 Bitcoin. Every 210,000 block, which is about every 4 years, that reward gets cut in half. And right now the reward is 6.25 Bitcoin per block. Bitcoin mining reward will disappear when the Bitcoin supply reaches 21 million. Right now, 19 million is circulating around the world. The expected date of all Bitcoins mined is the year 2140. None of us will even be alive to see it. Maybe our grandchildren will?